Hello everyone, and welcome to Jumper Man Tech, where we specialize in HVAC but do everything DIY. And today we have a service call for a 2-pipe fan coil unit. Thank you to everyone tuning in to Jumper Man Tech. It is a nice chilly day in New York City. Today we have a service call for a 2-pipe fan coil unit. Let's go ahead and see what's going on. Here we have a pretty decent sized 2-pipe fan coil unit. These wires though, man, does that look confusing? Luckily I have some experience with these, so I can tell you right. Whoa, what was that? System is in heating mode right now on the thermostat. I can tell you right now we got 2 heaters in here. You can see these very large thick wires, and that's going to be for the heaters. We have a relay here, and on this small wires, I know that's the coil. This side is going to be the contact, so there's going to be 120 here. And then you see it feeds 2 thick wires, these 2 thick pink wires. That's telling me that we got 2 electrical heaters here. I see 2 pink big wires coming in and 2 white thick wires coming out. This is 2 sources of 120 volts, so there's 2 120 volt heaters in here. All right. Set my meter to amps. Let's see if those heaters are pulling amps. I did notice one thing, that the filter was filthy. All right, no amps on this heater. No amps on this heater. Okay. Do we have coil voltage? It's hard to see in here, but let's see, across the coil. Across the coil we have 120 volts. But this relay should be energized. We should have 0 volts across. And we have 0 volts across. Let's check to ground. We should have 120 to ground on that one. Okay, incoming power, yes. And then incoming power to the heaters. Okay, thermostat is working. Auto changeover switch is working. Because we are in cooling season, it senses that the water is, let's see, where is it? Whew. See, switch is right here. It senses that the water is cold, and because the water is cold, it is auto directing the voltage to go to this electrical heater. So we have chilled water, so instead of opening up the actuator, because we would actually get cooling in that case, it is going to energize the electrical heat relay, which it is doing. The relay is doing its thing. Just make sure there's no other heaters in here. Oh man, I see a black thing in there, man. I wonder if these things burnt out. That's bad. That's really bad. So everything's doing its thing, but the heater is not working. Either the temperature sensor in there, like an overload, got too hot and burnt out, or the electric heat strips are actually bad. This unit was on when I came here. Look at this coil. Excuse me, the filter. Dude. That thing is done. That thing hasn't been changed in years, my boy. And we got dirt squeezing in through here. Oh man, that's wild. That's crazy. Thing is done. That heater could have easily went off on overload, and if that overload or limit switch, whatever you guys want to call it, wasn't good for some reason, that heater is done. If you guys can see that, look at that black stain right there. It's starting to look like it burnt in there. Oh, it might be these wires. Look how they put tape on it. If you guys can see, look, they put black tape. This thing probably shorted out at some point. Oh man, we gotta take this apart. We gotta take this thing apart. Let's inspect those heaters, man. Unreal. Let's turn this thing on off. Let's see, is there a switch somewhere? Alright, power's off. We'll confirm that. Well, let's take off this cover right here for the fan. Look at this thing, everything's loose and everything. Man. So the heater's behind the fan motor. Man. And that motor has been replaced, I can see. Oh, that's nice. Just squeezing this by. Gotta get a bit inside there, but if I take this off too, I can just pull this out and kind of put it to the side. But guys, this filter has been done ages ago. It's like a rug at this point. Packed city. All right, last time it was changed, August 9th, 2022. Guys, it is mid-November. It's like November 14th right now, it's 2023. Yeah. All right. Might have some slack on these wires. Okay. There's 4 screws holding this plate. We should be able to pull it all out, but maybe I could take off this thing right here and we just slide this thing to the side. I need access to these heaters. I'm telling you guys need one of these angle bits for your drill. I think it's a lifesaver, man. Let's take off this cover fully. Okay. That cover's out. 5/16, and over here, so dusty, you can't even see the screw. It's a Phillips head. Okay. So we got 4 screws, and we could take out this whole plate. One, 2, and 3, 4 on that edge, and this whole thing should come down. All right, last one. Okay. A little lip on the top. Okay. Gotta find a place to rest that. The heaters are up there. See, we got 2 of them, like I mentioned. Let me just balance this out. Okay. Got 2 heaters right here. What the? You got a piece of plastic in here. That's from the fan blade. Awesome. Okay, so I like to visually inspect it because sometimes you can see these things are just burnt off. All right. Like these little heater strips, they're like burnt off. Okay, let's figure this out. There's only 2 screws holding it. I might pull one out. Let's just test this thing. Either way, man. It's either the heater itself or this sensor right here. Let's see what it is. Okay, that is one. How to properly test this thing. All right, red. Okay, so the red or pink wire on top. Neutral on the bottom. Let's test this thing. Okay, so if we look at this, got two connections here, in, out. So we took off wires here. Okay, so this is the heater itself, and this right here is the sensor. I wanna disconnect this one, isolate it so we don't get any feedbacks. And then let's check resistance across the coil here, and then check resistance and continuity across this little sensor. Trying to think of what I tested the other heaters for. I think it was like, if it was good, I think it had like 39 ohms. $13.2, and there is continuity. Wonder if it's like, see if I check over here, it's like a 30 connection. $13.2 ohms. I'm wondering though, is this 208 volts or what? Can't see, but there is continuity there. I mean, that's good. What about this switch? You see, there's nothing. There's nothing. So this thing might have a chance, but this right here, yeah, this right here is done. All right, that's great. I'm not hot wiring this, man. You need some kind of safety. I'm not gonna be responsible for no electrical fires. Let's go ahead and check the other one. I think this sensor just fried because, and I think it's because of the filter. So whenever they say maintenance is a scam, well, no, it's not. If you guys properly maintain this, you guys wouldn't have heat. This is a hotel. You'd have heat and a happy customer. Somebody's actually checking in today in a couple hours, and it just is what it is. That's definitely the 5-star experience, guys. 5-star experience. So that's beautiful. Let's check the other heater. All right, my parking meter just went off, but let me just test this quick. Because if anything, I'll go and try to get that sensor, the overload, thermal sensor, whatever you want to call it. All right, that's that. Let's isolate one of these. Okay. Real quick. And do the same test. I'm gonna check across the switch, the overload. Done. Let's check the coil. 13.2. It might be all right. It might be all right. I think the other heaters that I was working on was 208 volts, and those had like 39 ohms that I read on the coil, on the heat strip, on the resistive element. Oh man, look at the dirt in there, man. This coil is kind of packed too. That's not helping this situation. Not gonna have proper airflow, and that's why this thing went bad. Okay. So I pulled off one of these on here. I'm gonna have to give it a shot and see. We need these. All right, let's see something. Let's get rid of this. Okay guys, I got rid of this jumper real quick, and I put direct 120 to this heater. I just want to do a quick check to see if those 13 ohms of resistance is actually a good reading for this type of heater. You can see that black mark a lot worse here, a lot better here. Man, it looks crazy. All right, Let's test this thing. I just want to do a quick test. You don't want to run this thing without the fan. Eight amps. All right. Oh, I can smell it too. I can smell the heater came on. All that dust in there is burning off. All right, guys, let's turn this switch back off. We need to get those limit switches. Here's the original control, just 2 screws. Took it off the heater, and I managed to get the 2 new controls. That's a beautiful thing. Let's go ahead and make that repair. It was just sitting in here, very simple. Just gonna drop that in there, match up the screw holes. Right there, drop in the 2 screws, and that's done. And just like that, it's in there. Let's go ahead and drop this one in there, wire it properly, and replace the other one. So just something to take a note of. Whenever you get resistance readings on something, on units that you work on, definitely want to write that down so you know in the future. So for the 208 ones, 39 ohms was good, and for the 120 volt ones, it's different. Seems like 13 ohms was good. So just something to take a note of. Definitely recommend you getting a workbook and writing down part numbers and things of that, and just tips on just how to do better. Let me blow this out, a little air or something. This thing is gross. Dust like that gave a little burning smell, but eventually he'll just burn it off. But you don't want that to go in the room because it might set off a fire alarm. All right, guys, while my battery was charging for the camera, I just put the 2 screws back over there and wired everything back the way it should be. Hot wire, let's see, comes in, goes into the control, out of the control to one side of our heat strip, and the other side of the heat strip goes back down to neutral. And that's how it is. I also was able to brush down the coil in the back. Definitely looks a lot better. This thing really needs some maintenance, but they need this back up and running as soon as possible. So we're gonna close it up. Just have some concerns over here. Look at these burn marks on these wires. This thing happened. I mean, who knows what else is going on. And maybe for good practice, I might even just change this relay. Guys, keep in mind, these heaters are over 20 years old. We just saved a dinosaur. So put back together, I actually just changed this relay because I'm a nice guy. It's a nice setup right there. I feel like it's only right. Everything is original and it's super old. Clearly there's problems here. The 2 new limit switches and the heat relay, they should be good for the season. All right, guys, everything looks good. All the connections are tight. Always double check those. And looks like we're ready to put this thing back. Let's get the screws on and zip on this motor. All right, let's put all of this back. This is the plate for the filter. This is the filter bracket. All right, slowly being put back together. We need to get a new filter here. The system on heat. I heard the relay engage. Come on, show me the money. I smell it. Nice. Got 8 amps on this one. And we got 8 amps on this one. And that's how you got heat, boys. That's how you do it. Oh man, that's a beautiful thing. Alright guys, we got rid of that terrible filter. Got a brand new one in there. Here's the supply air grill. I got 91.6 degrees now and slowly climbing in medium speed. For this kind of system, the lower the fan speed, the higher the temperatures where there is going to be for this electric style of heat in here. So it's slowly climbing, which is good, and this is definitely working better than others in this building. We're gonna wrap this one up here. If anyone found this video interesting or helpful, please drop a like, comment, and subscribe as I come out with new videos every week. And I'll catch you all next time.